Hello, audience. Welcome again to our next topic for today. And thanks for tuning in to World Ocean Week, organized by 8X Pixel Virtual Expo. Today, we have our next topic on marine conservation in Asia, student edition. Okay, and I'm very, very happy to have our student panelists and speakers on board. Before I go into details, I'd like to introduce myself. I'm Carter Lee, organizer for 8X Pixel Virtual Expo. And today we have Lala Grace from Philippines. Her research area is on giant clams project, research assistant, and she's also doing her master now with Marine at Marine Science Institute. Hi, Lala.
Hi.
Next up, we have Reza. He's from Indonesia. He is currently at a research center for oceanography, and she's also from Indonesia Institute of Science. Hi, Reza.
Hi, nice to see you all.
And next up, we have Samuel Chan from Singapore, the Sunshine Island. His research area is on coral reef monitoring, and he's from National University of Singapore. Hi, Samuel.
Hello.
Okay, next up we have Suneha. She's from India. She is the project head for artificial reef and sustainable fisheries program. Okay, and she's doing her Quest and also from Quest Academy. Hi, Suneha. And last but not least, we have Rabitha. She's from Malaysia. Okay, she's doing her dynamic interaction of current circulation in the South China Sea. Hi, Rabitha. So right now we have students from all over the world and from different universities. So they would like to, Abe has invited them to share their expertise in their own areas and towards how they can contribute towards the marine conservation in Asia waters. So I would like to start off with Samuel from Singapore to share what he's working on and how he is contributing towards marine conservation. Samuel, please.
Okay, hi everyone. I'm Samuel. I'm a PhD student in the National University of Singapore. I'm in the Department of Biological Sciences and I'm working in the Reef Ecology Lab. So this is me right here diving in one of the islands called Pulau Jong, which is somewhere south of Singapore, which is where most of our coral reefs are. And these are some of the people that I actually work with. And I'll just talk to you briefly about some of my research on how these actually help to benefit conservation in Singapore and in Asia in general. So firstly, I think I'll just talk about this problem of a shifting baseline. So basically, in the past, we don't really know what the reefs of Singapore or even most of the world looks like because we don't have information on these reefs. So we can't really go back in time, say 100 years to what the reefs of the past look like. So what we have to do is use different pieces of information that we can get. And this information is very important because if we don't know what the past looks like, we don't actually know how to actually better conserve the current state of the environment and how this will actually look like in the future. So one part of my research started with this video from this German explorer in the past in Singapore. So he actually came in 1958, which is quite a long time ago. And he actually took all these videos which are in black and white because there's no color at the time. And he actually managed to get some pictures of the reefs in Singapore in the past. And remarkably, a lot of these reefs actually look similar to what we have today. So we don't really see this difference, but we don't know if this is actually has been the case for even back before 1958, because we all know that Raffles landed in Singapore in 1819. So that's actually a very long time for development to take place. And all this development actually took place in the south part of Singapore. So actually these can have a lot of impacts on the reefs as well. So what we do is we actually get this very long aluminum pipes and we actually hammer them and drill them down. So you can see that this is not an individual effort. It's actually a lot of people working together to try to get the information of the reefs. So what we do is after drilling these down, we actually get the entire pipe back up. So some of these actually reach up to 2 to 3 meters. And one of them is shown in the right here. So for example, you can see that there's a lot of coral rubble at the start, and then there's some big coral pieces as well in the middle. So these are actually the different species of corals. And when we actually clean them out and identify all these, we can actually see what the species are of the past. And then we can compare the abundances of these species in the past to the present day. So we can actually see some of the red colored circles, which actually represents radiocarbon dates that we have gotten. So these are sort of trying to tell like what they do in archaeology, where they actually use the radioactive carbon ratio in these coral skeletons, and to see what is the age of these skeletons at that area at that point in time. So you can see that actually some of these are actually 7,000 years old, which is a really long time ago, and way before even Raffles landed. So this is one part of my research that tries to find out what the past was like, so that we can actually know how to better conserve the present day reefs. The second part of my research really looks at monitoring in the present day. So we all sort of know that coral reefs are actually present all around the world, but they're actually concentrated very highly in the Coral Triangle, which Singapore is just slightly outside of. So we're sort of close by, and that these areas have a lot of threats. We all know coral bleaching, which is very prominent nowadays, but there's also local stresses and all these other threats. So coral monitoring actually takes a lot of effort, and a lot of people need to go down and survey them one by one. And this can actually take a very long time. And together with the help of this group of people, which is the Global Coral Reef Monitoring Network. So this is sort of a group of volunteer scientists that actually came together to monitor reefs in East Asia. So this includes all the way from north to Japan and all the way down south to Indonesia. So everything in between as well. So basically what we're trying to do is to come up with a regional report, and then together with the global team, a global report to identify what the reefs of this region is doing. And then we actually want to sort of give a better understanding of how the reefs are doing today and in the last, say, 30 to 40 years, because that's the amount of information we have. And this information actually helps. It's not just from scientists alone. It actually comes together with NGOs, various partners from all around Asia, and actually these people have actually contributed a lot of data. And as I mentioned, right, that reef monitoring takes a lot of work. It's really impossible for one person to do it alone. So actually, a lot of our work is done together with a lot of people, and all these people actually help to contribute these efforts into helping us understand what the coral reefs are like today. Yeah, that's all. Thank you.
Thank you, Samuel. I'd like to move on to our next student speaker to speak about his research area. I'd like to have Reza, please. Reza, you are muted.
Okay. Is it okay?
Awesome.
Okay, my laptop is not showing right now. Sorry. Okay, hello everyone. My name is Reza. I'm a researcher in the Marine Pollution Research Group in the Research Center for Oceanography in the Indonesian Institute of Sciences. Well, actually, I prefer to call myself the waste picker than the researcher, because I'm taking any waste in the kind of beach or coral reef or any other area. So my field interest right now is on the marine pollution, ecotoxicology, environmental stress, particularly to the marine plastic debris and microplastic. So today I'm going to talk about the marine litter or the marine debris. That, as we know, that the marine debris is a human-created waste. That, well, quoting the UNEP, the United Nations Environmental Program, I have to say that marine plastic debris, particularly the marine plastic, is the new toxic time bomb that not only entangling or drowning the wildlife, but it also, being mistaken for food ingest by, along with its toxic contaminant. So the marine plastic, and in particular microplastic, provide the global transport medium for the most toxic chemical into the marine life or the marine food chain, and ultimately to the human. So at the present, marine plastic debris has been identified as the global problem alongside the other key issues for our time, including the climate change, the ocean acidification, sea level rise, and also the loss of biodiversity. So how much the plastic debris in the ocean? The number are really staggering. You can see the number here. Over 5 trillion pieces of plastic debris in the ocean, over that mass, over that 250,000 metric tons floating on the surface. According to the figure from Jaganathan back 2015, around 4.8 until 12.7 million metric ton per year were ended in the ocean. It's really big number. And from this picture, you can see Asia is the, the big hotspot, plastic from the land to the world ocean. So we have the direct impact of the marine plastic debris. The first one I already told you, the entanglement and also the ingestion. Both of them, not both of them, that entanglement and ingestion of the marine debris can be fatal because it has the direct impact. One study reported over 600 species that affected by the marine plastic debris, and it's increasing each year. Over 1 million marine animal, including mammals, fish, shark, turtle, bird, are killed each year due to the plastic debris in the ocean. And how about the environment? Take a sample like this one is the plastic debris in the coral reef. Simon already told about this, and then the plastic are threatening the coral reef ecosystem because plastic debris not only causes the direct physical damage, but also carrying the pathogen within and between the reefs. They can also promote the spread and increasing the risk of infection. It can also cause the declining of fish production. It's really bad because I really love to eat fish. So I want to protect the coral reef from the plastic pollution. Do I hurt so greedy right now? So the last one, because this one is the big one, and this is the other time bomb. We can call it the microplastic, the small plastic litter that has size less than 5 millimeter or half of centimeter. The bigger problem on the microplastic in here because we didn't know the real consequences. The microplastics come from the various source. We can call it like the primary source and the secondary source. The primary source, all of us maybe use it. If you see the back of the composition from the soap or from the fish scrub or something else, you can see there's quite a lot of microbeads. And sorry, I forgot. And the second one is the secondary microplastic. That is the result of larger pieces of plastic breaking down, like you can see from here. We can say that the plastic doesn't disappear; it's just invisible, not invisible. So the microplastic, either the primary and the secondary plastic, they unchanged through the waterway into the ocean. The aquatic life and the bird can mistake the microplastic for food. The microplastic can ingest by the fish, crustacean, that can be subsequently consumed by human as the end of the like the end of the food chain. Plastic also can, the microplastic, the big one and the small one, they can also bring food chain toxin. They produce the toxic production when the plastic break down. There were so many additional researchers that have found the evidence of microplastic have become chemically associated with the, for example, like the heavy metal, organic pollutant, or I don't know, the other pollutant that while in the water or maybe in the, what's it called? In the air. And this chemical has been linked to variety of health problem, including the reproductive harm or obesity, plus the organ problem and developmental delays in children. Currently, we only knew that there are potential environmental risks by microplastic. However, the real consequences are unknown because there's still kind of limited research. Well, actually, right now the research is being conducted, but there is still too much that we don't know. So I can say that we have to we don't want this prediction to happen, right? Because in the next 40 years, there will be microplastic abundance if we compare it with the plankton. So if we keep the current increased rate of the plastic consumption right now and the current plastic of waste generation, we have to taking care of that also. It will be a big disaster for us. And then the last word is there is I and you in the solution. We can do better for the environment. So I think that's all. 5 minutes is really tough. Thank you for listening. Oh, sorry, I forgot.
All right, thank you, Reza. I'd like to have our next student speaker up, which her name is Lala. Lala.
Yes.
Sorry, Sue.
Can we ask questions? I do have a question for Reza.
Sure. Go ahead before we go to next.
Yes. So Reza, you were talking, first of all, I loved your talk. I found it so interesting in so many aspects that I had not thought of earlier. But you had spoken about, you showed the map earlier, right? That said that Asia contributes to most of the plastic that comes from land to sea. Now, do these figures also include the waste that is sent as recycling exported from the West to Asian countries? Or is it all indigenous, like local waste that we are generating ourselves?
It's really hard to answer, actually. It's a really political one. But to be honest, both of them contribute to our plastic consumption. And then, like Indonesia, China, India, Philippines, Malaysia, they're kind of export the waste from the European countries or the American countries, and then we kind of recycle it. And then, I don't know, we have to do the research first. I'm really afraid if I answer it right now, my government will be kind of angry to me. But yeah, to be honest, that things, the waste that exported to our countries that can contribute the plastic waste that going to our seas. Yeah.
Thank you.
Any questions from the panelists before we move on to the next student panel speaker? Nora, you have any?
Hi, Kata. Hi, everyone. I think those questions, I just leave it at the end so that we can have a very conducive round-table discussion. Yes,
Okay.
Reza, I have a lot of questions for you, man.
Yeah, I have a few lined up, actually. Okay, so without further ado, let's move on to Lala. Lala, please.
I'll share screen first. Oops. Okay. So hello everyone, I am Lala and I'm from the Philippines. I'm currently working with the Giant Clam Team program and also a master's student in UP Marine Science Institute. So today I will share with you our efforts in the Philippines in conserving the giant clams. So firstly, I'll just introduce you what are giant clams. So giant clams is considered as the largest bivalve mollusk. They are relatives of oysters, mussels, and cockles. And as a large marine organism, they significantly contribute to coral reef health. Giant clams are unique and they are also similar to corals because they have a symbiotic relationship with the algae called zooxanthellae. And because of that, they become photosynthetic. Along with that, they also have large gills inside their body that could filter water particles and could contribute to the cleanliness of the ocean water. So, due to its several functions, they are very important in our coral reefs, primarily because, yes, they contribute to primary productivity since they have a photosynthetic ability. And then their mantles, the mantle of the giant clams is a food resource to various species of fish. And also, the juveniles of giant clams can be food for echinoderms also. So they have a shelter. The shells of the giant clams could be a shelter and habitat to various organisms such as corals and sponge, and then other small fishes. And with its large shell made of calcium carbonate, it could also add to the topographic complexity of coral reefs. And as I've mentioned, they filter ocean water, and they could also indicate reef health because they could bleach just corals. So they are in grave danger actually, and it is because they are overexploited due to their beautiful shells and large meat. So their meat are eaten by locals, and their shells are used for ornaments. So along with that, exploitative harvesting of these giant clams does not only destroy the organism, but it could destroy coral reef areas. And our giant clams are also vulnerable to changing climate, since I've mentioned before that they are sensitive to environmental stress, and they could bleach and eventually die. With over harvesting and over exploitation, destructive fishing, along with this, giant clams are vulnerable because they are actually slow to mature. It takes 8 years for the giant clam to reproduce uh, juveniles. So in the Philippines, actually, the Tridacna gaigas in the 1980s were considered locally extinct here in the Philippines. So because of that, the late Dr. Edgardo Gomez started the giant clam culture here in Bolinao, Pangasinan, and it is a restocking effort to replenish the population of the Tridacna gaigas, different parts of our country. So it starts with induced spawning and then maintenance for juveniles. And then as they grow older, we restock them to different parts of the Philippines. And of course, we like to involve and make effort for the stakeholders to be involved in our advocacy, so we educate them on basic knowledge and on how to protect our giant clams. So this is an ongoing project. The restocking efforts, we're still doing it, and there are additional efforts, just like our new project, which is funded by the government. So we are assessing different areas in the Philippines to check on our wild stocks, and then to check on the restocked clams if they have produced juveniles in the wild without intervention. And then we're also trying to improve our culture techniques for the improvement of the giant clam spawning and maintenance. So as I've mentioned, we have continuous efforts for restocking. As a matter of fact, I have a map here, and it shows the different areas where we've restocked our clams since the 1980s. And fortunately, because of the effort of Dr. Gomez, there have been several institutes that are also contributing to the restocking efforts. So you can see here in the red circles. And then recently we've discovered that there are several parts in our country that the restocked giant clams were able to produce juveniles, and it's a very exciting news for us, since it is an indication that they could be sustainable in the near future. And also, as I've mentioned, education and conservation workshops for local communities, government officials, and then NGOs. And lastly, we try to involve ordinary citizens, educate them on the importance of giant clams, and also uh, give them options on how to help our conservation efforts. So, as a takeaway, I'd like to uh, remind that giant clam is an important organism in our reef, and recently it was considered as top 5 of the functionally unique, specialized, and endangered species. So if exploitation and overharvesting continues rampantly in the next few years, giant clam would be extinct in several years after. And this can not only happen to giant clams, but other organisms as well. So I think we should conserve and protect all organisms, whether big or small. So I think that's all. And thank you for this opportunity.
Thank you, Lala, for your giant clam presentation. I have a question for you at the end of the talk. So now, next up, we will have Rabitha from Malaysia sharing her research area. Rabitha, please.
Hi, everyone. So thank you. First of all, thank you for having me with you guys today. Let me share my screen. So can you guys see my screen? All right. A bit introduction about myself. So my name is Rabitha Daud. I graduated my PhD in physical oceanography from Institute of Oceanography and Environment, University Malaysia Terengganu last year in August 2019. And currently I'm working as a lecturer teaching for the civil engineering students at the University Technology Mara UiTM Shah Alam Selangor. A bit about my research background. So basically, myself more on the ocean modeling. So some of the programming that I'm using is Regional Ocean Modeling System, ROMS, if you guys familiar with. And also, I'm working for the most part is I'm working for the current circulations in our oceans, looking at the ocean mixing in the water columns, and also between the seas in our regions, and also Pacific Ocean and Indian Ocean into the South China Sea. Some of my work, I'm also working on the coastal dynamic, which is we were looking for the coastal erosions and also sedimentations, basically in Malaysia, more specifically in the east coast of Peninsula Malaysia. And I also have experience working on the marine dispersions in terms of the fish larvae, data hatchling, and also for the transportation. So meaning that the water transport, taking example the salt, heat in our oceans, and then how they move from Pacific into the South China Sea, and then how they came in out based on the seasonal monsoons. Part of that, I'm also working with the satellite data. So basically, my part is working on the physical or oceanographic data. So looking at this data set, it's really helpful because we can help for the marine biologists, marine chemists, how to understand the data sets. Taking example, like you guys that working with the Lala, that working with the giant clams, and Reza working with the microplastics, and like how the distribution of these microplastics in our regions, transport and distributes around the seas and between the seas and the oceans. Right. So before moving, I would like to give a bit overview or a bit background what we have in our backyard. Yeah. So especially in the South China Sea. So this part is the current circulation pattern in southern South China Sea and Gulf of Thailand. So basically we have the South China Sea basins, right? So we start in Luzon Straits and the Kalimata Straits. A part of it in the China region. So I consider the southern South China Sea meaning that the one that's lower by nearby the Singapore, Indonesia, Malaysia, and Thailand. So these regions. Yeah. So we have the southern South China Sea and also the Gulf of Thailand in this part. So this is a model simulation showing you the sea surface temperature and also the arrow showing you the current circulation in our region. So as you can see, sometimes we have the recirculation here. Yeah, it's called AD, so we call it ED, so which is recirculations, and that's where we have it's really good for the ocean mixing in this region. So in general, so because our region is largely dominated by the two monsoon seasons, right? We have the southwest monsoon and we have the northeast monsoon. So largely because of the winds, so basically how the winds blow. So southwest monsoon means that we have the winds that blow to the northward regions, and during northeast monsoon we have the winds that blow to the southwest regions. All right. And during the southwest monsoon we have the northward currents, and during northeast monsoon we have the southward currents. And what the interesting part is during southwest monsoon, basically in Malaysia, that we have a high intensity of the cool water spotted in this area, which is along the east coast of Peninsula Malaysia. So this high cool water basically associated with most of the time associated with the upwelling event, because the upwelling, the coastal upwelling event means that where you have the wind that blows the parallel to the coastline, so with this direction, and then the surface water is carried away by the winds, right? The movements, so it leaves an empty space of white space on the surface. So thus it pushes the water that from the bottom up to the surface. So where you have the upwelling. So the upwelling event is really important, specifically for the productivity, marine biodiversity, because it brings rich nutrient waters from the bottom to the surface. So basically all the fish, they don't really have to dive down to the bottom layer of the water columns to get the nutrients, and also you could spot the coral reef and the seagrass for the productivity, for the growth. It's basically like fertilizers in our oceans. So it's give cool water here and it's flow towards the Vietnamese coast. But meanwhile, during this season also we have the thermal fronts, so which is the warmer, the interaction between the cool water that's coming from here, the southern parts of the Peninsula Malaysia, and also the warmer water that's coming from the northern parts, which is coming from the Gulf of Thailand. So these kind of thermal fronts, or mixing of the hot and cold temperature water, seawater, is really important and play important roles for the marine ecosystem. So basically, taking an example for the coral reef. So either we have too much of temperature change, like too warmer water, so then the coral tend to bleach, right? So to lead to the coral bleaching. But with this kind of thermal fronts, like cool water and warm water, that it gives a suitable temperature, just nice for the coral to grow. And during office monsoon, we really receive cool water that's coming from the northern parts into our regions, and really strong current. So between these two seasons, the northeast monsoon is largely dominated, like bring a stronger currents compared to the southwest monsoon season. And basically, these figures showing you guys roughly the schematic diagram of the surface current flow in our regions. So we have the December, January, February, March, April, May. So we have the southward currents. So this is the main current directions. And during June, July, August, September, October, November, we have northward. June, July, August, we have a northward current flow, and the rest of the year we have the largely southward current flow. Right. So from this experience, like all the data sets like current flow and sea surface temperature, salinity. So what are the applications? Where we can give the contributions parts. So in my study, normally we're using it. We are working in the team with the marine biologists, with the conservations for the sea turtle conservation see-through at our university, and also with the satellite data with the biology teams that working with the polychaetes, bivalve, right? So the first part here I'm showing you one of our projects is looking for the coastal upwelling in thermal fronts. So this is as explained to you. So this is a very show clearly in the whole genre of the South China Sea regions. So how it flows is the currents coming from the Kalimata Straits, and somehow it gets intense here and then carried to the along the Vietnamese coast, right? And then we can see that warmer currents from the Gulf of Thailand is coming from the Gulf of Thailand. And the other part is also working with for the sea turtle hatchling, so which is the baby, the sea turtle baby. So it's really the Chagam Bay, the Radang Island. So basically, this is part of the Radang Island, if you're familiar with the measurement. So we have a Radang Island here, and then we have one bay that's specific for the sea turtles conservation work. So we do the simulation work, which is we would like to see where's the potential that this hatchling go when they leave the beach. No, when the hatchling leave the beach during that time. And then we do the simulation. So most of the time when we are during the northeast monsoon season, so possibly there are high chances that the turtles go to the southward, which is they swim towards the, basically the hatchlings don't really swim because it is still small, but then they just follow the surface currents, the ocean's currents, yeah. And then most of the time, they follow the surface currents that towards the Kalimatan Straits, and most possibly towards the Indian Oceans through the Java Straits here. And then meanwhile, during the southwest monsoon seasons, there is high the chances that sea turtles going up towards the Gulf of Thailand, and also the possibility that, because if you still remember that the current circulation is circulate, so most of them will go up along the Vietnam coast and towards the Luzon Straits, and then later on to the Pacific Ocean. So basically, if the turtles actually during the August, which is the southwest monsoon, so most of them probably may end up to the Pacific Oceans. Meanwhile, those turtles that hatch leave the beach during the northeast monsoon season in December, January. So they most probably start their journey in the Indian Ocean, right? And the other works that have been done this year, this part is looking for the microplastic distributions. It's really interesting that looking here, listening to the result of this presentation just now, and I would like to highlight this part of the work that we use the model simulations, ocean simulation, which we foresee the ocean current, sea salinity, the density, and the movement, and also the winds. And then we try to predict and forecast what kind of distributions of the microplastic that we have in our area. So what we have here during June, July, August, so when we relieve the 1,000 of microplastics particles from the Tioman Islands. So if you notice, the Tioman Islands basically is somewhere here. So just nearby the upwelling area. It's along the east coast of Peninsula Malaysia. So most of the time during the southwest monsoon, most of the plastics, microplastic will distribute to the northern regions, right? And then during the September, October, and November, most of it will end up along the Borneo coastal water here, and also some part of the Kalimantan here. Right? Meanwhile, during the December, January, February, and most of them tend to go to the northern regions, but they also have they get into the Kalimantan Strait and Java Sea here because of the strong current that they have, and also the mixing ocean mixing during these seasons. And during March, April, May, so some of it will end up in the Gulf of Thailand, Vietnam coast, Spratly Islands in this region, and some even that can get to the Philippines and then towards the Luzon Straits. So basically, in terms of to understand more in terms of the productivity of the marine biology and chemistry, what's going on in our ocean, it's really important to have a bit overview of the physical parts of the physical characteristics. Take example, the temperature, seasonal, and ocean currents. Because most of the dynamic, like the mixing of the water, take example, like South China Sea is we are really blessed with the semi-enclosed basins, because we have the Luzon Strait on the northern parts that connect us with the Pacific Oceans. And the southern part, we have Kalimatan Strait that connects us to the Indian Ocean. So basically during the southwest monsoon, it brings a new water, like it's not really new water, but then it brings a new water from southern parts of the regions into our area, into the South China Sea. And then during the northeast monsoon, we receive another new water coming from the Pacific Ocean from the northern region. So this explains why, even though that Reza mentions that in our region, like we are in the countries that use lots of plastics, but based on the data, when we do the field work that we try to collect the microplastic samples, the abundance or the percentage of the microplastics in our basins is not really represents based on the usage of the plastic that we have in our country, meaning that the samples is quite a bit lower compared to the how the usage of the plastics in our regions. So the reason, one of the reasons, because of these unique current circulations, the seasonal monsoon season that we have, because whatever that we have in our basins, it will carry out through the Luzon Strait during the southwest monsoon, and whatever that we have in the basins, it will carry away to the southern parts of towards the Indian Oceans during the northeast monsoon season. So basically, we already see that new refresh the water in our basin, and that's the unique of the ocean mixings in our regions. Yeah, I guess that is so far for my explanations, and then I'll leave if there are any questions later towards the end.
All right, next up we have Suneha, sorry, wrong pronunciation, Suneha, who will be doing her research presentation. Suneha, please.
Thank you, Carter, and thank you all for the amazing presentations that the rest of the panelists have done. I've learned a lot. So I will just start by sharing my screen. One moment. One minute, I'm sorry. Okay, can everyone see my screen? Okay, cool. So hi, my name is Suneha. I am an independent marine biologist from India. Basically, what I do is I conceptualize and implement marine education, conservation, and research projects in the Indian coastline. But today I would like to focus on this region of the Indian coastline. As you can see on the map over here, it's called the Park Bay. So this part is a small bay in the Indian Ocean that is sandwiched between India on the west and Sri Lanka on the east. Now, this is an extremely productive part of the Indian Ocean, and it has a lot of native seagrass beds as well as coral reefs. However, this also means that it is one of the most overfished regions in our entire country. And what started out as a small scale local community driven livelihood has now become a very large scale globalized industry. Now, I don't need to focus too much on the ill effects of overfishing, so I'm going to go over this part quite quickly, but most of you might already know. So apart from the obvious ecological impacts of overfishing, we have habitat loss, we have a loss of biodiversity. Of course, all this also contributes to global climate change. We also have a lot of large-scale economic impacts within the country. Overfishing does negatively impact both the fishing industry as well as the tourism industry, which both employ a lot of people in our country, and they both rely on a healthy ocean for it to survive. In addition to this, the loss of jobs and the loss of breakdown of the economy also leads on a social level an increase in crime as well as poverty amongst the smaller communities. Of course, this also has a political impact between two countries which share maritime spaces and borders, which is India and Sri Lanka. So this being the main problem that we face across the Indian coastline, I partnered with a travel company, a tourism company called Quest Academy to build artificial reefs. Now, artificial reefs, to explain it in a very, very simplified manner, is essentially the same as you do as reforestation on land. We're essentially building homes for fish underwater. So what we do is we deploy artificial reefs that are made out of completely locally sourced materials. All our artificial reefs are made out of concrete. So these reefs essentially act as a substrate. It recruits a lot of fish. Fish are the first ones to come to any artificial reef because they're mobile and they can make decisions in terms of what habitats they prefer. In addition to that, it also recruits a lot of benthic invertebrates. Now, invertebrates, for those of you who are watching it from home who are not aware, are any animals that don't have a backbone. So that is anything from sponges and tunicates to the giant clams that Lala was speaking about, as well as your corals. So you have an initial recruitment of usually what would be sponges, tunicates, as well as different species of mollusks on a reef, following which we have recruitment of other invertebrates such as coral once the substrate is what we term is favorable for the growth of coral. Now, keep in mind that concrete is essentially chemically quite similar to coral skeletons. It's essentially calcium carbonate itself. So this does provide a very conducive environment for the growth of coral. Along with this, we also have the breeding of fish and other invertebrates that are happening side by side as the reef develops. And over the next few years, we hope that this will help us establish a fully functioning marine benthic ecosystem. So what we are doing is we're not actually transplanting coral, but we're just providing a substrate for coral to naturally regenerate in the region. So this essentially, what we're doing is we're sort of giving it what you can call a stepping stone for the corals to regrow on their own. So to better help you understand the project and the context, I do have a video that I've put together. Dutch, could you please play the video? and see a completely dead region. But of course, when you go for a dive and you see a region that has been brought back from the dead, that gives a lot of hope for any diver to.
All right. I think it's good video that Suneha have shared. So now we come to a Q&A session. So it will be coming out from the audience and also some of the questions that Nora and myself have, and also I believe some of the panel speaker have some of their burning question as well. So let's take this chance to get the question out and have a great Q&A ahead. Nora, please. Nora, can you hear me?
Yes, just give me a moment. Okay, everybody's on gallery now. All right. Okay, so thank you so much for the presentation. It was very insightful and learned a lot actually. I think the ADEX community and us have learned quite a bit about the ocean. All right, we do have some question with Rabitha. Rabitha, don't look shocked. Okay, so Rabitha, yesterday we had a presentation from one of the assistant professor from University of Warwick. He actually specializes in models and also currents as well. And he kind of mentioned that at certain periods of the year, because of the current movement, like for example, plastic waste from, let's say, distributed maybe from the UK will arrive somewhere near to Malaysia within I don't know, a certain period of time, and then after that it will push the current will push itself away to another location, and then it kind of like toggle within different venues. So perhaps you could share with us a little bit on that portion. In terms of currents, especially regards to plastic or any waste, ocean pollution that is being pushed to Malaysia or any parts of the world within that region.
All right. So thank you, Nora, for the question. Hello. So thank you, Nora, for the questions. So basically, so the so there is like plastics, there are two types. Like the Reza mentioned before, that the microplastics and the macroplastics, which is the bigger one, and the smaller, the tiny particle size, that's become microplastics. So basically, the oceans currently play important roles to transport these plastics around the world. That's very surprising nowadays, that how come the plastic that coming from UK, that Nora mentioned before, that we end up somewhere in our backyard, which is in our South China Sea basins, that's very basic, because ocean itself, like the whole world, that we have the ocean conveyor belts, so which is all the current circulation. So basically, they are interconnected to each other. So meaning that the water that's coming from the Atlantic oceans that possibly transport to the Pacific oceans, and then afterward Indian oceans and South China Sea, and then get back to the Atlantic oceans. So that how the water in our oceans flows. But it does within all the time, like how long did they, how many years that it take long years to complete that one cycle of the ocean circulations. Right? For the microplastics, yeah, they do impossible. Again, that because of the current flow, and then the unique thing because of the in our region. So basically, in Asia regions, because we have the Asian monsoon systems, right? And then it keeps changing throughout the year. And then so basically, most of the time we define it 4 seasons, which is we have a northeast monsoon, November, December, January. That is a really strong one basically in our region, which is Singapore, Indonesia, Malaysia. But compared to the Indian regions, so you are largely dominated by the southwest monsoon seasons. Yeah, and then in between, we have the intermonsoon. So between the intermonsoon, basically the changes from southwest monsoon to the northeast monsoon, and northeast monsoon, southwest monsoon. So during this period of time, so basically we have a quite slower currents, and also a weak wind forcing, wind blowing. So during this time, possibly that's where we have a weak forcing that to transport all these microplastics. So that where normally they will end up to at the shore or towards the beach. It depends on which location they are. But during the strong monsoons, basically southwest monsoon, northeast monsoon, so they just keep flowing, follow the current flow. And then again, as I mentioned that before earlier, that even though Indonesia, Malaysia, and Thailand, now we are using lots of plastics, but really rare to see the plastics. Take example like drinking waters like floating in our oceans. Just like what they find nowadays, that if you're familiar with the terms, that ocean garbage patch in the Pacific Ocean, where we have because of, I still remember that from my presentation that we have the recirculations in the Gulf of Thailand, just the opening of the Gulf of Thailand. So that's really worried us, because that's where most probably that we're gonna have, if we possible, to have the garbage patch in our regions. So that would possibly be the place. Because when you have the recirculations, that everything we try to accumulate in that particular spot. But the other interesting part is only seasonal ADs, which is the recirculations, because it's only occur during the southwest monsoon. But in the larger scale, in the Pacific Ocean, it occur along the year. So where do we have the accumulates of the garbage, all the marine debris, that whatever the plastics or garbage that we throw to the oceans, where they accumulate there. And once we have the oceans, the Pacific Ocean reach its capacity to hold on to the plastics, so it will, all the plastic that still going into our oceans, they will end up to somewhere else. So meaning that when we have the pools of the Pacific, full load with the plastics, so we move to the Atlantic oceans. And afterwards, probably perhaps the Indian oceans. And then afterwards, the last part will be the small seas like the South China Sea. But the trends is already basically in the Mediterranean Sea. They start to see the trends where they start spotting the few places where they have the garbage patch in that region, in that sea. Yeah.
Thank you, Rabitha. That was very insightful. How about having Reza add on to this topic, since we're talking about plastic?
It's really interesting one. I have one model, but I haven't finished it yet. It's really related to Rabitha's research. Can I show one slide of it? Is it okay? Okay. So I just put it. Okay. Yeah, this one. So we tried to, make the prediction where does the trash coming from. Like, for example, we have one island in here. Oh, sorry, I forgot. Yeah. Oop, it's not showing. Okay. Oh, sorry. My mistake. So we tried to make the simulation like this one. We have a Bintan Island. It's really close to Singapore. And also we have an area in Medan, in Jakarta, in Semarang. This is kind of a backward trajectory simulation. I don't know. I'm not really know about the modeling. Maybe Rabitha can show this, but from her presentation, there were so many trash in here. Maybe it's coming, because from the sea line transportation, right? So, but it's really showing that the debris, either the macro one or the microplastic one, it doesn't has the ID card, so they can go anywhere around the globe by, like the drifting in the ocean. It's really complicated right now. We haven't tried to finish the modeling yet, but maybe we can collaborate somehow, Rabitha. It's an interesting one, right?
It's really interesting one. Sorry, Reza. Yeah, it's really interesting model. You see, that perhaps if we get that, you can share the screen because this part, even though in your model it's still showing that some of the seasonal trends, the seasonal current circulations in the distribution of the plastic that you have there, even though it's still early of the research, but we can see the patterns there. So from my models, so because we release it from the east coast of Peninsula Malaysia, so that's why at the beginning, so we have like all the track is coming from there, and then it's really interesting to see your simulations here. So most of them we end up in the Java Sea, and then perhaps if we have higher abundance of the plastics, so we might see they get into the Indian Ocean.
So basically in our case, we in Indonesia, we already just finished on December last year. We what's it called? We tried to monitor 18 beach around Indonesia, but we haven't put all the area in here. And it's really complicated right now. We tried to simulate it like for 1 year or 360 days, but until now we didn't know how to do the real validation, how to use the ROMs, the modeling one, the regional. My colleague did that, but she is now going to China for continuing her study, so I lost her. So we could collaborate to do the trajectory particle modeling, and we can working together to tackle the plastic debris in our region. I guess maybe not only us in Indonesia, Malaysia, but also from Philippines, also the Singapore, Cambodia, Thailand, any other Southeast Asia countries, right?
Yeah, sure.
Thank you. The reason of why we're doing this is all about collaboration, because to me, I think when we talk, when we collaborate, that's where we can further push our research and our works. My next question actually is from the Facebook viewer. So this one, she would like to ask Suneha. Suneha, how sustainable are these artificial reef modules? How many species of corals were transplanted? So there's two questions there.
So that's actually a really, really interesting question. So first of all, to address the second part of the question, as I'd mentioned earlier, we are not transplanting coral. We're just providing a substrate for the coral to naturally recruit upon the reef. So we're not into transplantation of coral or handling of coral directly. Now, to go to the first part of this person's question, how sustainable are these artificial reef modules? So the sustainability of any artificial reef has multiple factors that you need to take into account. Firstly is how sustainable are the actual materials that we're using. We use concrete for our artificial reefs, and this is a relatively inert inert material to be using. It doesn't react too much with the ocean water. And in addition to that, it also is a very solid and heavy reef. Each single module weighs up to around 200 kilograms. So this not just means that chemically it is safe to put in the water, it also means that it's quite resistant to action from trawlers and large scale fishing boats. So it's not just about how sustainable the materials are, but how long will this reef actually last? And which is one question, which is definitely it will last at least for the next 15 to 20 years, because of the fact that it is so resistant to being toppled over by fishing boats. And secondly, also another thing that not a lot of people tend to think about is how sustainably are you procuring the materials for your reef. Now, if I want to build a reef, but I'm getting materials flown in from China and the US and different parts of the world, the carbon footprint of each of these artificial reefs is going to offset any good that it would possibly do. So what we do is we are locally procuring these materials. The furthest we go is 15 to 20 minutes away to the next village to get them everything from the molds to the actual material that we're using for the actual concrete that we're using for the reefs are all locally sourced materials. So not only does this reduce the carbon footprint, it also enables us to be able to follow through with the next part of the project, which would ideally be to train the local fishermen how to use and construct these reefs, so that when time comes and they do have to and want to construct these reefs in order for them to be put in the forefront of their own conservation projects, they're not really dependent on an external party. They don't need to go and ask the government for funding. They don't need to ask a private company or a scientist or anybody for funding. Anyone should be able to build these, any fisherman should be able to build these reefs and put it out there in a place that honestly, fishermen know the ocean better than anyone else. So they should be able to do this on their own as well. They shouldn't be dependent on an external person or an organization. So that also went into account when we decided how to construct these reefs and what to use in order to construct these reefs. And finally, the last aspect of sustainability, because it's such a large scope, is what sustainability really is how viable and successful would the artificial reef even be? Now, if I go and put down an artificial reef really, really far from any natural ecosystem, yes, it may still attract a lot of local marine biodiversity, but it might take a lot longer for an ecosystem to actually develop. So we have put down the artificial reefs around a couple of kilometers away from a natural reef ecosystem, and the area that we selected previously did have coral reefs. So it is a place where corals can possibly regrow and regenerate, and the physical and chemical conditions allow that to happen. And finally, also, it needs to be in a place that can actually benefit the local fishermen, because the idea behind a project like this is to enhance fish catch. So it cannot be, say, 20 kilometers from the coast where you have this beautiful reef, but none of the local community is actually benefiting from it. So again, it is situated in a place that is accessible to the local fishermen as well. And that also ties into the sustainability factor of the artificial reef. I hope I've been able to address this question in a concise manner.
Thanks, Suneha. I just have a question though. With the materials that you use for to create that artificial reef, those kind of structures, do you normally use organic materials, or do you use those metal plastic framework?
So the molds, I'm assuming you're talking about the molds that we're using to construct the artificial reef. Okay, so they are not organic, they are plastic derived. But what we do is after we remove the mold out of each reef, we stitch the molds back together so they can be reused. Everything from the PVC pipes that we use to actually make the structural complexity in the reef to the outside blue mold that you saw in the video, they're all reused each time. So one mold that you purchase can be used multiple times, and it's not something that it can be used once and it's thrown away.
Thanks, Suneha. I know of an organization that does a lot on organic and also materials in terms of the framework. I'm not too sure whether you've heard of Ocean Global Quest.
No, but it would be great if you could pass on their information to me and I can get in touch with them for my reefs.
I'll connect you to the founder, Anwar Abdullah. I think you guys can work together. Okay,
Yes.
yes, Kata, you want to ask a question, I see.
Yes, actually, this question is from Sam, and it's actually to all the panelists. She thanks the panelists for engaging the community in marine conservation. But what are some of the challenges that each panelist face here? Some of the example challenges in communication and legislation, and how do you guys overcome? A bit of politics, but how do you guys overcome it? Shall we start off with Sue again?
Yeah, I'm just trying to think of there's, of course, I think every conservationist or aspiring conservationist faces a lot of issues in terms of communication, as Sam had pointed out. I don't think the problem is communicating with people who are already interested, because there are a lot of people out there, especially divers, who are invested in marine conservation. One challenge I have noticed, though, is there is a huge, at least in India, I've noticed that there is a big divide in mentality between the diving community and the fishing community. There's often pitted against each other, and they're seen as people on the opposite sides of the spectrum. But I've always found it hard to communicate that at the end of the day, we're all fighting the same fight and we need to stay united. And it's not fair to say that a fisherman is doing something that's wrong or bad because he's fishing, because he's been fishing a lot longer than we've been diving. And he's been doing what he does a lot longer than we have, to be entirely honest. We're much newer to the game. So I think that is a challenge that I've faced in terms of trying to. I'm nowhere close to being able to bridge that disconnect, but I have faced that challenge in terms of disconnect between divers and fishermen.
How about Lala? Is there any communication barrier or legislation that you face in Philippines?
So, because our conservation efforts already started way, way past before, and we've done forums and seminars, and we've noticed that a lot of still local communities are not aware of the laws that we have in protecting the giant clams. And I think that's the challenge is that how to communicate to the locals. And I do agree with Suneha with what she said about the fisher folk should not be a barrier to this conservation effort, because they should be part of this effort. And we try to make them understand that this conservation effort is for them. And I think that is one big challenge, but we do try to bridge the gap between the fisher folks and the scientific community, and of course the conservation issues. So yeah, we've done a lot of seminars, and I think the fisher folks are more responsive now also to the conservation efforts that we've done recently.
Lala, can I just ask you a little bit of a question with regards to this giant coral clams? In your region itself, in the Philippines itself, how many species of such clams are available right now? Because I do know that a couple of species are labeled endangered. So can you just share with us a little bit on that portion, and also how do you embark into creating that kind of awareness on such endangered species within the community itself, and also to the government, please?
Also, there are 8 species of giant clams here in the Philippines, and 3 of them are vulnerable under the IUCN, and the other 4 are conservation dependent, and the one is lower risk. So the government is well aware, since they have been funding us with researches on giant clams. But what we do so that the audience or the ordinary citizens would know, we have social media accounts to publish all of our knowledge, Also, we do interviews with newspapers and also show segments so that other people would understand the importance of giant clams. And yeah, and I think there are also lots of venues like what I've said, forums, and then there are exhibits where we talk to students and local communities and local citizens of a municipality, where we talk about how to protect them, and that's what we do here in the Philippines.
Yes,
All
I think
right,
that,
thanks.
sorry to cut in, but I just wanted to say that I think it's amazing that you guys are speaking to the local students, because that's where we can actually make a difference, right? Because the children are the ones that actually want to make any change in their lives and will actually go ahead and do that. So that's really amazing.
Very true, very true. I would like to return to my question again, but I would like to share. Samuel, I will have you last to answer the question, because I understand that you work with some regional leaders. So is there any roadblocks that you face in communication and legislation issues for Reza from Indonesia? I think Reza froze up. Yeah.
My mistake.
Yeah.
Sorry. Sorry. So, what did you say again? Sorry, I forgot.
Sorry. Okay. Is there any communication roadblocks or any communication issues you face, and some of the legislation about conservation that you want to pass or you work with to pass through with the government sector?
Oh, sorry.
In Indonesia.
Since I forgot to unmute my microphone, I forgot the question. So the first one, the problem is the management plan in Indonesia is not really good. We have the plan, but to implement it somehow, it's really hard to do that. There were so many, there's like the boundary and regulatory area that, for example, the Ministry of A said that we have to take the fish, and then the other ministry we have to taking care of the area and something like that. In Indonesia, there were so many problems because there's like the political one. So that's why I agree with Suneha and also with Lala that we have to talk to the community in the area, for example, to the village leader or to the like the NGOs, local NGOs in there, and then and the other problem are coming out because mostly the people in Indonesia, like the fishermen, they live in the low poverty, right? So they think first they want what kind of food they eat like for tomorrow. So so the challenge is like that we have to talk to them that the ecosystem, the marine ecosystem, the economy is the economy asset. And then, for example, like when we are talking about the marine litter, we talk to them that we can, separate the plastic and then we can sell it, and then they can make the money for, and they can buy the food. And then there's also the different tribe in Indonesia. They have a different what kind of a different mindset. So maybe in Indonesia we have more than 700 tribes. They have different culture, different things. So each area that if we want to talk about the marine conservation for each tribe, we have to on the kind of a different different communication one. So that's why we have to go to the village leader first, and then, hey, we have something like this, and then this one is the benefit for you, and then what we can do for the next management or for the next time or something like that. You got what I mean? Thank you.
Yes, yeah, I do. So the same question to Rabitha. How is Malaysia? How do you tackle this in Malaysia then?
For in Malaysia, so normally because so we do have the challenges between the battles between development and environment. So which one we should consider the more important one, right? So it's either we want to develop the area. So take an example, coastal engineering. You want to build the ports or the airport runways or any structure on the beach, and later on which will lead to the coastal erosion. Right, so the sedimentation which will do damage to the coral reef in the area, right? So, but the battle is always between either you want this kind of development, the highways or the better transportation highways in the area, or you want to preserve the coral reef, the water, the seawater there, or the fish habitats there. So it's always the battle between the state government, with the governments, and we are as the researcher parts, but then we try to do our best, which is whatever that they propose, any project they propose, we try to make it, if that might be harmful to our marine habitats, so then we try to find another alternative. Like take an example, perhaps instead of you making the extensions to the coastal water, so why not you move into inland, towards the inland. Right, so that we try to protect. And the second part is the mindsets of the community. So same goes with the other people talking before. And for taking example for myself, because I'm teaching a lecturer at the university now, and it's really I really make use of this opportunity because in fact I'm teaching the engineering students, but I also share with them about the oceans, about the marines, because I believe that 70% of the planets are covered by the oceans. Like there's a really huge percentage, means that when we have the healthy oceans, that we have the healthy planets, right? So the idea was when we try to give that awareness, so that later on, because these are the engineers, right? So when they get into the career, like they're working as a career, as an engineer, so they involved with the project itself. So at least they have the power there to fight for the marines, for the oceans, right? for the environment, right? Then other than that, we also do the community projects. So we go to the schools and all, school kids, yeah. Right. So that's how we handle the challenges in our field in Malaysia. So basically in our teams, yeah. Right.
Thank you, Rabitha, for that sharing. Last but not least, Samuel, the same question to you. I mean, as Singaporeans, I mean, we in Singapore we have this sister island, which is a marine sanctuary now. How will you progress this to more marine sanctuary in Singapore waters? I mean, I understand that you work with Singapore leaders, the regional leaders. So how could you help Singapore waters and the conservation efforts in Singapore waters?
Yeah, I think maybe just to start off, I think looking at it at just a country level is not so great as well, because the seas are quite open, right? We know from the circulation stuff that Rabitha mentioned and the problems that Reza mentioned that all these problems are actually more regional and actually global if you think about it. And so with a lot of the things we do, like in the Global Coral Reef Monitoring Network, we're actually working together to try to see what's the problem in the region and try to bring the solution out. And then I think some of these, how we can apply this to Singapore is that when the information of this regional and global level is created, we can actually disseminate this to the government leaders and maybe help to influence policy this way. So the science might not be so easily understood by policy leaders because they're not trained in biology like we have. So we really need to try to get this message across, which might be technical, and try to condense it into a more easily understood way to these government leaders, and then they can actually help us to bring this message to the government to make some changes as well.
Nice sharing, Samuel. I think we are running out of time. I believe there's more questions, but feel free to post on Facebook. We'll get those student panelists to answer as much as possible. I'd like to hand over to Nora to close off this topic and panel. Nora, please.
Thank you, Kata. So once again, I would like to thank every single one of you who took the time out and to actually share your research and studies. The idea of us convening all of you here at the moment is all about collaborations. When we talk about the ocean and also the science behind it and the current state of it, I think we ourselves or within our region itself, we can't do it all together by ourselves. We need to convene and get and collaborate and cross-platform and see how we can further push our studies, of course. Thank you once again, to Rabitha for sharing with us a very insightful knowledge about the oceans and the currents and I don't know, like what you just shared just now, like where microplastic actually end up with and stuff like that, and where are the zones, the spots too. Samuel, thank you very much for your time. I'm sure you're a very busy man, and thank you for sharing with us your insights on studies with regards to corals and everything that we can know about Singapore. Don't think that Singapore has no corals that we cannot dive into. Yes, we do. And also, I would like to thank Lala for sharing with us a little bit more on the knowledge of giant clams, which, to be honest, I'm quite a noob at it. I'm not too sure about that. But thank you for sharing. And I do hope that, we can do our part to save this endangered species. I would also like to thank Suneha, all the way from India, to, working with us to get this thing together. And thank you so much for sharing your work in India with regards to artificial reefs. And I'm sure if you need any support, do let us know. We would love to hear your story in India, and hope to catch you soon when we do visit India for edX. And last but not least, we'd like to say thank you to Muhammad Reza for sharing us with information of microplastic. Although this is not my first session talking to him with regards to this topic, but I think there's more that we can talk about, because it's not only environmental issue, but it also has becoming a health issue to the public as well. So thank you once again, and we'll catch up soon. Thank you.
Thank you, everybody. Bye.